Hello everyone. In this video I'll make a short tutorial in which I'll show the steps for creating a custom PCB. First, we will open a new project on EasyEDA. For this demonstration, I'll make an LED strip that can be controlled by a microprocessor. We'll start by designing our schematic diagram. This is where we plan and build our circuit. Because I want to control the LEDs with a microcontroller, I have to start with female header pins for the holes. Notice that I can choose the symbols, meaning it shows to me how it'll look on the final design. Once I place the holes, I can start to plan what will be connected to them on the board. I will start with the resistors, since they control the current that reaches the LEDs, so it is customary to plan it this way. As you can see, I place the default value of 10k ohm, but in reality I'll need to place a 220 ohm resistor in order for the LED to light up brightly. It is important to notice the type of footprint that the components have, meaning how they will affect the board with holes, silver plates, or solder points. I added a G&D point so the current will flow from the microcontroller to G&D through the LED. After I've made the basic LED plus R, I'm copy and pasting it in order to save in time and effort of rebuilding it. To connect the components, I can either use the wire tool or click the edge of the component and it'll let me connect it to the other component's pins. I've made sure to leave out one pin, so I'll be able to connect the microcontroller's GN. It is important to remember these little things in order to make sure that everything is wired up correctly. If you miss these little things, it can lead to a lot of headaches. Now, when I'm done with the schematic, I can click the Convert to PCB bottom in the top right corner. This action will take all the components we placed and convert them to the corresponding footprint. Because I've made changes in the schematic, it makes sure that I want to update my PCB design. The software finished converting all the components to footprints, and now I can start designing my PCB. I'll start by marking the board around my components. When that's done, I will arrange the components inside in a way that shows what's first from the pins. Make it a little bigger so it's easier to work with. I'll move the components around with a cursor and rotate them by pressing the spacebar. Usually we'll place the resistors first and then the LED. The thin blue lines you're seeing are the connections that are supposed to be made but haven't been created yet. I'll use them to know how to orient the components relatively to VCC and G. I'll place each part so the plus side is facing up and the negative side is facing down. To move all my components at once, I will mark them with a left click and drag them to the location. The arrow keys can be used here. Now when it's all set and done, I can start marking the connections to the microcontroller. This is a very important step in order to make sure that everyone will be able to understand what goes where, even if they're not familiar with the process of making a PCB. I will mark the pin connections with a clear text, while making sure to indicate where's ground and where's VIC. Repeat these steps for all pins. Double-click to edit text. Don't forget that one of them is ground, and it matters which one, so use the blue lines as guidance for what goes where. Select all the red TXT by holding CTRL while pressing them. Change the layer to top silk. This way the text will be printed on with a white easily visible text. Cleaning the non-important text so we won't waste space. And shrinking the board to the required size, since bigger boards are considered unnecessary and will greatly affect the manufacturing cost when buying in bulk. Now that we're finsight with the planning of the board, we'll start the wiring using the auto-route tool provided by the EasyEDA software. First click route and then auto-routing. This is the auto-route rules. This is where we select the width and max turn angle for the automated connections. For safe design, we'll have 45 degrees angled turns, since right turns can cause issues later on. Now that our routing is complete, the PCB is considered finished, and we can watch the preview of the final product in 3D image. The software has converted our design to a legitimate board with all the footprints and components in place. The 3D model is a bit hard to navigate, but not too hard to understand how. You can see the connections on the board. This is how it will look in real life too. Can also look at it in 2D. We'll only show the footprints and holes. Since our design is very simple, there are no connection on the bottom side. The auto router connected it all on top side. You can also add something unique to your design to show people it's yours. I will add a made by in the bottom side. This way it won't be in the way of any components and I'll have enough space to write whatever. Once again, I will change the font size so it fits nicely within the regions available to me on the PCB. And we'll select the layer to be bottom silk. This way it will be written clearly under the board in white text. Since we're working with a 2D space, it will appear to have been flipped and mirrored, but do not worry, this means it worked properly, and I'll just drag it to wherever I want it to be on the board, while considering it is on the bottom side. Let's check it out. Orient it so it is easier to read. Awesome. Now to manufacturing our part. We'll first click CTRLs to save our progress. And then we'll export our manufacturing file, Gerber file, to JLCPCB website. We first have to run the automated design rule code check in order to make sure we have no crossing cables or missing connections. Once that's done, we can click Order PCB, or extract the Gerber file ourselves and upload it to JLCPCB. This will be done by first clicking on the PCB fabrication file bottom, and then selecting Export Gerber file. We'll run the DRC again just to make sure. And then save the Gerber file with an appropriate name. Since I've already saved it, I'll click Cancel, but if you haven't downloaded the updated Gerber file, you need to download it here. Now we will go to jlcpcb.com. And log in to our account. Create a new account or log in to your existing one. Now click the Instant Quote button to upload your Gerber file. Here you can finally upload your final file. Click Add Gerber file and add your downloaded Gerber file. Uploading. Now that the upload is finished, you can see a preview of your board design. Please know that you only receive the board, without the components, unless you choose PCB assembly. If I see enough demand, I'll make a video explaining the assembly process by the manufacturer with that in mind. Please make sure to use the right components with the right footprint. For example, the footprint I used is for an SMD resistor, meaning it's super small and it's not the normal one that you can solder on. As you can see, it is really cheap, at just $4,000 total. That is, unless I choose the right quantity, of course. I can also choose what color my board will be, but this comes with a downside of added cost and build time. There are a lot of additional settings, but the default is usually alright for these kind of simple boards. I'll remove the make model number because it is irrelevant for my tiny prototype PCB. Here you can ask for the PCB assembly, but please research before turning it on blindly. There are steps that must be taken before in order to ensure a working and cheap board. The stencil option is for advanced creators that know what parts to order individually and how to solder them on with the proper parts. This is not relevant for this basic video. Because the design is simple, one layer will do. More layers equals more money. I will also change the shipment carrier since it is not urgent and the slower route is significantly cheaper. As you can see, the color change adds a lot of money for some reason, so I will keep it the default green this time since it's only cosmetic. The cost has reduced significantly and is now the same as a couple of snacks, which is fair since the minimum amount is 5 boards. It is good to make sure you know exactly what you're paying for. This way you can ensure you're getting the best value for your project. And since a lot of the costs can be reduced, it should cost around $5, shipping excluded. Now that I'm satisfied with the board and costs, I can save the product to my cart and purchase it. Total price, shipping included, is around a McDonald's meal, but I think you shouldn't try to eat it. From here, it's just payment and shipping. Here are a couple of examples of PCBs I designed myself using these softwares and ordered from JLCPCB. This is the end of the video. I hope I helped you learn a thing or two. See ya.